Hey everyone, Mr. Voikin here. This is lesson 3.1.2, and we're going to begin with a quick review of the last lesson where we were looking at arithmetic and geometric sequences. So the sequence and pattern on the left is an arithmetic sequence. That means it has a common difference, which means we're going to either be adding or subtracting another number to the previous number. So to determine the common difference, we're going to take term 2 and subtract term 1. That is going to be negative 8 minus negative 16, which is the same as negative 8 plus 16, which is going to equal 8. So our common difference is 8. So what is the rule? We're going to add 8 to the previous number. Now, we already know it's an arithmetic sequence, and it has a common difference of plus 8, so we now just need to apply that. So we take the last term, which is 4, we're going to add 8. 4 plus 8 is 12, 12 plus 8 is 20, and 20 plus 8 is 28. Okay, now let's move over to the second review, which is a geometric sequence. And we know that a geometric sequence has a common ratio. If it has a common ratio, then we know we're either going to be multiplying or dividing to find the next term. So how do we find the common ratio? It is term 2 divided by term 1. Okay, so term 2 is negative 6 divided by negative 18. 6 divided by 18 is going to still leave us with a fraction, but 6 can divide into both of those. 6 is a factor of 6 and 18, so we end up with 1 over 3. Now I need to deal with those integers, the negatives. Negative divided by a negative gives us a positive. So what is the rule? The rule is we will be multiplying by 1 over 3. And that is the same as dividing by 3 in this case. So now I need to find my next 3 terms. Just going to move this out of the way here. Okay, so to find my next 3 terms, I'm going to take the last term that I have, which is negative 2, and I'm going to multiply it by 1 over 3. Negative 2 times 1 is negative 2, and that's over 3. Remember, this negative 2 could be placed over 1, and that's how we multiply through with fractions. So my next term happens to be negative 2 over 3. Now I'm going to multiply that by 1 over 3, and I get negative 2 over 9. And I'll multiply that by 1 over 3, and I end up with negative 2 over 27. And at that point, we're done. Okay, so here's the vocabulary that we'll be using for this lesson, and it's important that you understand how to use these vocabulary and understand what they mean, because I will be using them in the lesson and within our questions. So this is a good time to pause the video and read through the vocabulary and make sure that you do completely understand what's here. If there are some problems with some understanding, then you can ask me in class to clarify it a little better. Okay, on to your keys to success. After completing this lesson, you need to be able to look at a formula or an equation and create a table of values. You need to be able to look at a linear relation equation and create a rule, similar to the rules that we made for patterns and sequences. And then you're going to have to look at the variables within an equation and then substitute those variables with known values to solve these expressions. Okay, let's take a look at example number 1. So it says complete a table of values using this given formula or this equation, and this reads as y equals 7x plus 2. Now, this is like the y is equal to 7 times the x plus 2, but we don't need the brackets in there, and we don't use multiplication symbol because we have the variable x that actually looks like a multiplication symbol. Now, y will depend on the other numbers that are with that variable x. So the number in front of the x, this is called the coefficient. And the number that is all alone by itself, this is called the constant. So the value of x is going to be multiplied by the coefficient, and then the constant will be added to that. Now on a table of values, we always start off with x on the left, which is our dependent variable, the one with the coefficient and the constant, and the y goes on the right. Now we just need to select a range of values for x and then substitute it into that x value and basically solve for y. So I like to start off with 0 and maybe do something like -1 and -3, 1 and 3. So get 0 and get a couple positive values and a couple negative values. So all I'm going to do is take my equation, which is y equals 7 times x. Well, let's start with 7 times -3 plus 2. Now we have y equals -21 plus 2, and now I have y equals -19. And we're just going to continue that through on each one of these. So now I have y equals 7 times, in this case, -1 plus 2, y equals -7 plus 2, y equals -5. And then we just fill it in across here. Now I just want you to finish the last 3 right there, pause the video, get that done, turn it back on, and you'll see the values that I have also calculated. Okay, so these are the values that you should have got after doing the work. Hopefully you got them right, and let's move on to example 2. All right, example 2. So we have another equation right here, another formula, except the variables are different. Instead of x and y, we've got g and f, but f is our dependent variable, so it's going to go first, and g will be here. For f, we'll create the same 5 values right here, and we will calculate g depending on those values of f. So we're just going to substitute these values of f into f and solve g. Okay, so the equation is g equals -3f plus 5. And now when you're placing the values in there, it's important that you're sort of putting it inside this bracket like this. Otherwise, if I don't put it inside a bracket, it ends up looking like -3 minus 3. So what I want to do is go -3 times f. What is f? It's -3 plus 5. So g equals -3 times -3 is a +9 plus 5, so g equals 14. Okay, and I'll do one more for you, and then same thing, I'll let you do the rest on your own. Okay, so we have g equals -3 times f plus 5. G equals -3 times -1 plus 5. G equals +3 plus 5. G equals 8. Okay, so pause the video, calculate the last 3. I don't know why I put a 5 down there. Let me change that. That should be a 3. Okay, calculate those last 3 values for g. Okay, so the next 3 values you should have got were 5, 2, and -1. Now notice this one right here where we have a value of, for the dependent variable f of 0, that it ends, the value of g just ends up being that constant value right there, because no matter what if I multiply a number by 0, it's always going to be 0. Okay, now the numbers you should have got are 5, 2, and -1. And take a close look at this one right here. So when the dependent variable, in this case f, has a value of 0, then for a linear relation, and that's what this is called a linear relation. And basically it's the equation that creates a straight line. And we'll learn more about that as we move along. But notice that when the dependent variable f has a value of 0, then the independent variable, which is g, has a value equal to the constant. All right, with example 3, I'm going to let you complete the table of values using the values that I input there for q, the dependent variable, and r, the independent variable. Just make sure that when you're looking at this side over here that you recognize there is a q squared up there. Okay, so pause the video, do the work, turn it back on, and check out to see if you did it correct. Alright, so the values you should have got are 14, 6, 5, 6, and 14. This will actually create not a straight line, and that's because of that squared value over the independent variable. This will actually make what we call a parabola, which is going to look like that. But again, you'll learn that later on. For now, as long as you can get that table of values correct, we're on the right track. All right, having completed examples 1, 2, and 3, that will give you enough to be able to work on questions 1 through 6 on page 103. Now I'm going to move on to the next section, which is going to be doing a lot of substitution. So substitution means taking the value, just like we did before with the table of values, and plugging them into the variable positions. Now in this case, we're going to be given both those values and asked to solve the value of this expression, The reason this is an expression is that if you look at this right here, it looks like an equation, but there is no equal sign. For this to be an equation, it would say something like 4i minus 3h plus negative 2h squared equals 18. Okay, now if it says equals a value, then it is an equation, but if there is no equal sign in there, we just call it an expression. So for substitution, all you're going to do is take the value for I, which is 2, and the value for h, which is 3, and substitute them into those positions. So let's do that. So 4 times I, and I always put a bracket there. It's just going to really help with those negative signs. Okay, so get in the habit of doing that and you'll make less mistakes. So 4 times I, what is I? It's 2. Minus 3 times h, what is h? It's 3. Plus negative 2 times h, what is h? It is 3 squared. Okay, so there's a lot there, but remember, we're just going to be following the rules of BEDMAS. Okay, so we want to make sure that we're looking inside the brackets, and the only one that has a position where there's something to do inside is this bracket right here and here, and inside we've got two things happening. We've got multiplication and we've got some exponents. So the first thing we're going to do is deal with those exponents. So over here inside this bracket, I still have a negative 2 times, in this case, 3 squared, which is 9. Okay, I still have something that I can do inside these main brackets right here, which is negative 2 times 9. So it's okay for me to keep those brackets there. Negative 2 times 9 is negative 18. Now I'm going to bring down this plus, put it right here, and I'm going to deal sort of with this little section right here, which is some multiplication. 3 times 3 is 9. So I'll bring down the 9, and then I will bring down that minus sign. And the last thing I need to deal with is this multiplication right here, which is 4 times 2, which happens to be 8. Okay, now I've got 8 minus 9 plus negative 18, which is the same as just 8 minus 9 minus 18. So we have no more brackets, we have no more exponents, we got no more division and multiplication. We're on to addition and subtraction, which we do from left to right. So 8 minus 9 is negative 17. Negative 17 minus 18 is going to give us a negative 35. Okay, so example 5, I'm going to let you do on your own because it's very similar to example 4, except that this expression is just laid out a little bit different. But you can see we have two variables, x and y. X equals 4, and that says I instead of y. Sorry about that. This should be a y equals negative 4. So I'm just going to substitute every y with a negative 4 and every x with a positive 4. Just make sure you use those brackets like I showed you, and be careful and follow the rules of BEDMAS. Okay, so pause your video, try to calculate the value of this expression, turn it back on, and you'll see the work that I did, and compare your work and answer to my work and answer. All right, so the answer you should have got after doing all the work is a negative 27. So if you didn't get that, just double check it with mine, see where you made your mistake, and if you're still having problems, we'll deal with it in class. Okay, now you should be able to complete question 8, A, C, and E, and 9, A, C, E, G, and I, and those are on page 104. And you are now responsible for finishing this one on your own, and then you will submit your notes and your work to me, and in class we will complete a question right here. Okay, we'll see you in class.